All right, good evening, everybody. My name is Yelena. I'm one of the teaching assistants in data analytics program. Today, we're going to discuss the decision tree classification in R, and this meeting is being recorded for people who were unable to attend. And if you are able to attend, you'll still be able to review the recording. All right, so here is today's agenda. And we're going to go through the decision tree method, including the data pre-processing, training and test set, and I'm going to show you two implementations of decision tree method. And I'll show you what packages you need to install for each implementation. I'll show you how to run the method, and I'm going to show you how to interpret the results. Then I'm going to look at the confusion matrix and some documentation, and there is a little bonus for people who pay undivided attention. All right? So, for the purpose of this lesson, this is a data set that we're going to use. It's called employee attrition data. And if you may remember, it's the same data set that I used when I did the introduction to R. And here, you see the preview of the first 10 data rows. Basically, the data set tracks if the employee stays in the company. And that's going to be our target variable that we're going to predict, right? And we know the person's satisfaction level with the job. We know how many years the person was with the company. We know how many hours on average the person worked per month. And we know what rating on the last performance review the person received, right? So now here I wrote down what you need to install. For your homework assignment, you're doing the C3, so you have to install the party package. Then if you decide to explore the RPart implementation for your assignment, here are the packages that you need to install. Confusion matrix, there are two ways to do it. This is the second way. You can use this caret package, and this one, fancy RPart plot. This is something bonus that I'm going to show you tonight. All right, but I'm going to show it to you at the end. Right? So now I'm going to go ahead and share my screen right now. Share my screen, and we're going to go over. So what I did, I wrote a couple scripts for you here. Basically, what I'm going to do now, first of all, the first line of code, this is a comment, right? And a comment helps me describe what to do. Right? I'm going to install the package called party, right? Because the basic idea here is that my goal is to predict if the employee is going to stay within the company, right? So we're going to build a model, and then suppose that I'll be looking at another person profile, another person data, and I should be able to use that model that I'm going to build to predict if that person will stay in the company, right? So here, this is a party package. I commented that out because I only need to install it once, and I already have it installed. Now, however, even though I have an installed package, the package is not available until I actually load it in memory. And to load it in memory, there are two ways. You can use the require command, or you can use the library command. We're going to use the library command in this case. So that will put package in memory. Now notice that here what I'm doing is I'm writing a script. And the reason is because I want my work to be reproducible. Then after this class, I want you guys to have a copy of the file. If I was doing the command in installation, I wouldn't have been able to, right? So that's the reason. You always want to save the work in the script. Now, so here it is. I loaded the package and it should be in memory. Now, what is my next step? Take a look at this. Now, I have to read my data, right? And the data is stored in a CSV file. Before I can read the data, I have to set the working directory. Working directory is a folder where R will attempt to look at by default. And I'm going to set this. I have a folder. I have a folder on my external hard drive, and I call it data set. And that's where I save the file. So I'm going to go ahead and do that. And what this does is that it sets the current working directory. And you can also see this, the title bar of the console window. It shows your current working directory. Now what I have to do is I have to read the data from CSV file into the R object. R, it's called the data frame, right? So now here, this is a file name, right? Header 2, it means that my first row of the data contains the column headings, and I want to read them in. And here, it means that it's a comma delimited file, right, CSV. But what I actually did was I took the original file from the web page that I showed you, right? I showed you the link. And I abbreviated the column names because I tried to make the typing a little bit easier. And I wanted to make the code a little bit more readable. So, alright, so let's run this command. Read CSV will allows loading data into the data frame. Now look at this. You have 11 variables, and this is a number of observations. Similarly, you can do the summary command, right? You can do the summary command to see the statistics of your data, and this is what you always want to do to just get familiar with what you have here. Now, let's go over what data pre-processing we need to do. Notice that one of your fields here is what? Unique identifier. So, does an employee ID really determine if the person is going to stay in the company? I don't think so, right? So, we want to always remove the unique identifier because it does not explicitly determine if the person will stay in the company, and it also ends up taking, the method ends up taking more computational resources to run. So we go ahead and remove it. Remember from the first class, how do we remove the variable? We're going to set it to null, uppercase null, right? And then to verify that the ID was removed, you can just run this command names, right? And you're going to check the list of variable names, and you see that ID is no longer in there. That's how you verify. Our next step is that we have to check for missing values. And we have to, well, first of all, we're going to check how many, right? We don't make decisions at the moment, but remember this command is going to return me the number of missing values for each variable. So let me see. Okay, now, of course, there is more than one way to do it, but I showed you this way, right? So this shows me that I have one person missing last evaluation rating, and I have 2 people missing average monthly hours. Not too bad, so that's what I'm gonna do. I'm going to replace the missing value with the variable mean. Look how I'm doing it. This is how you get the mean. Remember that? So here is the mean part, and here it means that when I calculate my mean, I want to ignore the missing values in the mean calculation. So here, this is what I'm doing. I'm replacing, see this is an A, this will return the index. It will return the row number where the variable is missing a value. And then I'm taking that and replacing it with a mean. So let's go ahead and run it. Now here, it's the same thing, but I have a different column, average monthly values. And it's supposed to replace the missing values with a mean. But I always like to verify the work before I continue further. So I'm going to run my first command here. The missing values are gone, right? Alright, and later as we start looking into how the tree looks like, it will make more sense while we do it, right? Now, another part here. You have variables, you have different variable types. We have a continuous variable, and we have discrete variables. The problem is here, some variables are discrete, but they're represented as numbers. And we actually want them to be factor. For this specific example, we want them to be factor. But if I look at this one, satisfaction level and last evaluation rating, I want to keep it as is. I could go ahead and run discretization, but there is no need for it, because the method itself will implement internal discretization. It will take care of being in for me. So if this is like this continuous, you don't need to do anything. You can just leave it. The only what I did was I took care of the missing values. And also, of course, you want to look at the variable skewness, and if the variable is really skewed, sometimes one reason to not use it in analysis, right? Like, for example, suppose that if everybody had spent 3 years, right, then I won't be interested in this variable, years spent. So you always have to look at the distribution. Now what I'm going to do is, based on the dataset description, I know that here attrition has two values. You either stay or not. We cannot have a value such as like 0.5, right? It's not a continuous, because it's not a continuous number. Because you cannot have half satisfied. It's either you cannot have rather half stayed in the company. You either stay or leave, right? And here also, if you have a work-related accident, you cannot have the decimal values, right? And also this one here, promotion in the last 5 years, it tells if you received the promotion over the last 5 years. So what I'm going to do here, I'm going to run the factor command on this one. It's because I don't want my method to look at them as a continuous, right? Now, what I have to do is, so I have my data set, it's 4,507 observations, and now I have 10 variables because I removed the ID. I'm going to build my model, but to make sure that my results are reproducible, right, I have to set the seed. So that sets a random value. Because what I'll be doing here now, I have to divide my data into the training and test set, because we want to avoid overfitting the model. So we take 70% of data and we're going to use it to build the model. And then we use the other 30% to validate how good our model is. So let's go ahead and run the setSeed command. Now what I'm doing here, I'm going to randomly create the train data and test data, right? So 30%, 70% and 30. You can play around, you can use 8 and 20, but that's a usual number. There we go. Now what I'm going to do is, I have to build the model. I'm going to run the C3 function. And now remember that C3 function is in the party package. I first had to load this in memory, which I did, right? Now what I'm going to do is run the model, but wait a minute. A model takes two input parameters. The first input parameter is my train data, right? It's the data set I'm using. And the next input parameter, this is called the formula. So this is a dependent variable that I'm predicting. Then I put tilde, and here I'm supposed to list the variables in the data set that I want to use as my predictors. Some good news. The C3 model also, it supports this wildcard character, dot. That means that I can take all remaining variables. I don't have to actually spell them out in here. It's not always the case. The method you're going to use in the next module, it's not going to be the case. For neural network, you would have to physically list the remaining variables. Here you don't. It supports the wildcard dot. So let's go ahead and build the model, but take a look at what I'm doing. I'm storing it in a variable, and I call the variable model. Let's go ahead and do it. Right now there is no output. It's because I stored my output in a variable. What I need to do now is I can run the print command and put this as an input parameter, or I can just do the model. When I do that, this is my output. I realize and I understand that it's really hard to read, but let's see here. So in the very top line, it's showing me which method I just ran, right? It's showing me that I just ran. There's a conditional inference tree, and there are 21 terminal nodes. terminal node is also called the leaf node. This is the last level of the tree, right? The very bottom. Now this is my dependent variable, right, or target variable. I'm going to predict if the person will stay with the company. 1 means stay, 0 means does not stay. Here is a list of my independent variables, right? The variables that I use as a predictor, and this is the size of my training set, right? Because see this? Yeah, train.data. This is the size of my training set. Now here, this is a textual representation of the model. I know, I realize it's not pretty, but let's take a look at this. So here, our first split, right? This is a root node, and actually, what I found it easier is to look at it in parallel. You want to plot this and look at the textual representation at the same time. So let's see. Let's keep this one for now, and let's plot this because that's my personal preference. I like to look at this and look at this representation at the same time. So now, take a look at this. It's a little bit hard to read, so what I do, I'm gonna do zoom, right? So let's take a look at it here first. This is a little bit simpler to understand. My first node is a satisfaction level. Okay, so what I'm doing here, I have to look at, is my satisfaction level below 4.6? If it is, this is the pass I take. Then my next step, I have to look at the years spent with a company. If I work in a company for less than 4 years, then this is the pass I take, right? Here, if I work more than 4 years, this is where I go. Now, suppose that I work less than 4 years. Now I have to look at my salary. And in this case, the data set tracks low, medium, high. It does not track the specific number, and so on. I have to traverse the tree until I arrive to the terminal node. In this case, I understand it's a little bit harder to read, but if you tweak some input parameters that I'll show you, you will see the information that the method shows for the terminal nodes, right? But also take a look at this. Each node has a number. Each node is labeled with a variable name, and you can change that too. Yes, you can change it. I'll show you. All right. So let's go ahead and minimize this window. Here it's basically, you read it the same way. See, this is my root node, and here it's just showing me the splitting criteria. So here, then I'm if, see this number one, if this here, satisfaction level, my satisfaction is below 4.6, I jump in here. Then I check at my years spent. If I spent less than 4 years, okay, then it's looking at my salary. And if you see this asterisk, it means that this is a leaf node, the terminal node. And here is the number of observation, or you can call it number of employees, right, that fall into this node. Basically, it's sort of like a profile of people, right? You can look at it this way. People who end up in this terminal node, they have a satisfaction level at or below 4.6. They worked for 4 or less years, and they were making a high salary, right? So here, the same way, right? See, you're looking at the salary, and here, see this, you're looking at the year spent, and then if you keep on going, there is another 1 year spent. So here, you're looking at people spent more than 4 years, right? Then you have to consider the projects worked on, right? Project worked on. And in your homework, I believe you need to look at which variables are more significant. But, well, to do that, you look at which variable appears more in a tree, right? Like satisfaction level is probably significant. And then you want to see, look at this, like project worked on. That one seems to appear a lot, right? That's how you do that. right? So this is a little bit challenging to read in the textual representation, so I recommend you guys read together. And also take a look at this here. You have a node number 8, and on the visual representation, nodes are also numbered. So you can kind of like look at this in parallel. That's what I like to do, right? See this node number 1, and if you go back, you also have a node number 1. Right, so now, suppose that my output is super long. Now this is what I can do. I can print part of the tree. I can start from the node 5. It's going to skip everything before the 5th node and print everything starting from node 5. So if I go up, see this 5 years spent. So I'm just gonna do this piece right here. And everything, all this split below it. It's going to start from 5, and it's going to print all of the children of node 5, right? It's going to print all of the, see this is 5, right? And will print all of the direct and indirect children of node 5. And you can play around, right? I'm just showing you that you can do the portion. Oh, this one, this drop parameter controls if I want to display my nodes at the same level, terminal nodes. If I set false, notice how it is, they're not lined up. But if I change it to true, it just cosmetics. This is how my tree is gonna look like. It's supposed to look like this. All the nodes are on the same level. Let me take a look at this. See this? All nodes are displayed on the same level. So this is just a matter of how it's an appearance, right? And there is more. There is way more on appearance. So let me close this out. You can control something like how terminal nodes look like. First of all, there is a little correction to the C3 exercise in this R version. The plot types are called simple and extended. It's not complex. That is called extended. So let me show, before we get to something complex, let me show you something simpler. So here, by default, the plot type is extended, right? This is the default. Now let me do this. Instead, I'm going to put type equals simple. I thought I had it in here already. Okay, type equals simple. Right? Let's try this. So what this will do? Oh, I have to put simple in a double quotes. Okay. Now, notice this. Before I did this, I had a histogram. Right? Now what I'm gonna do? What I get for my terminal nodes is gonna be different. It's showing me the number of observations on the number of employees that fall into each node, and here is a percentage. Out of 112 employees, I have about 89% are 0, which means 0 stands for they did not stay, and 0.1 they stayed. So here it's just showing me the percentage. It's showing me percentage of people who stayed and percentage of people who did not stay, right? For each node. It's just a different view. Instead of seeing the histograms, I'm gonna see this, or rather the bar plots. Okay, now, this is what I'm gonna show you here. You can change the tree appearance further. There is something called the inner nodes. The inner nodes are the non-terminal nodes, right? So this is not in your exercise nodes, but take a look at this. This node, non-terminal node, this is called the inner nodes, right? And I can change how they appear. I can show numbers and I can remove numbers. I can abbreviate the variable names. I can choose to show p-values and not show p-values. For the terminal nodes, I can hide the numbers. I can change the color. See, this is the node background color and so on. So to do that, what I did here, this. I put model, and here I don't want to see the plots of terminal nodes. So that's simple. I call it simple. Inner panel. Inner panel defines the non-terminal nodes, right? Nodes that are not at the very end. It takes the model as an input parameter, abbreviates, specifies if I want to see only the first letter of a variable name. Here it shows, it means if I want to see the p-values, and if I want to show the node ID, I can show height. And here, terminal nodes, this basically shows how my terminal nodes or leaf nodes look like. The number of digits, I can change color, I can remove the ID, and so on. So let's go ahead and run this thing. Here we go. Now let me zoom in. Okay, take a look. What I did here, I asked to explicitly show only one letter. Abbreviation will show just the first letter in a variable name. Then what I did, I asked to remove the p-values, and I asked to remove the node number. Then for the terminal node, I changed the color. I only want to show the one digit. In here, in the percentages, I chose to show just one digit after the comma, right? So, like here, there are 9. Here we have 9 people, and I wanted to show just one digit, so it's 100%. Fall on the value 0 and 0 on value 1. Remember, value 1 means the person keeps employed, right? Okay, now let me close this out. So basically, this is your visualization options. Now we're going to look at the confusion matrix. Confusion matrix is a cross tabulation. I want to see how many people who actually left the company were predicted as they're going to leave, and how many people who did not leave were predicted as they're not going to leave, and how many people predicted as they're going to leave, they did not leave, and vice versa, right? So now, this is how I build my confusion matrix, but the problem is, just by looking at it, it's very difficult for me to understand where are my actual values and where are my predicted values. So let me show you something. There is another input parameter that the table command takes. The parameter is called DNN, and it will add the labels to the column and to the row. So here, what I'm doing actually, here predict. This one is, I'm going to do the confusion matrix for this is still for the training set. I'm not doing anything with the test data. I have to look at my classification accuracy for the training data and compare with classification accuracy for the test data. Because if the numbers differ too much, then it means that my model might be overfitting or underfitting the training data, right? So let's go ahead and see what happens. Let me run this one. And in your homework assignment, feel free to reuse this. I was actually going to update the exercise and put it like this. Okay? Because this is... Okay, take a look at this. So here, this is our row label, and this is our column label. So the way you read it is that this is the predicted. So I predicted I have 2,342 employees who I predicted correctly that they're not going to remain in the company. Then here I have 274 employees. I predicted that they will stay, and they in fact did. I have 32 people who actually did not stay, but I predicted they would stay. And here I have 74 people who I predicted they were going to not stay, but they actually stayed. And because of that, I can use it to do the to calculate the classification accuracy. Basically, take a look at this. I have to take my numbers on a diagonal, right? Notice that it does not matter how many classes you got. Always the correct predictions would fall on a diagonal from top left to bottom right. I had to find the sum of these numbers and divide by total number in the matrix. So this is how you do this. Length is the number of instances in the training set, and here this is what I'm doing. I'm counting in how many instances have a predicted value equal to an actual value. Right? This is what it does. And this is going to give me the classification accuracy for the training data. It's kind of high, right? So, well, who knows? There could be a risk of the overfitting. If the classification accuracy is too high, keep in mind we could be overfitting the model. So now let's take a look at this. I'm going to check the model for my test data. To do that, you have to do the predict function. You pass the model. The new data is going to be the test data, and we're going to predict the class, right? I have to predict the class, so I have to specify method class. And I'm going to store it in a variable called test prediction. I'm storing it in a variable. Now what I'm going to do, same logic, I'm going to build my confusion matrix, right? And now I want to calculate my classification accuracy. Well, okay, look at this. This is a little bit lower, right? But this is fine. We are about 1% lower. However, if I had only like 70% in here and 96% here, I would be very concerned, because that would indicate that my model might be overfitting the training data. That would be a problem, but here it's relatively equal classification accuracy. Well, for your homework, you don't need to get it in the 90s. If it's in the 70s even, that's fine, but you have to explain it, right? As long as you explain. Now, there are interesting parameters. Here, you can control the depth of the tree. Like, for instance, I can say, let me go down just 3 levels. But here, of course, it will have an impact on the classification accuracy, of course. Now, let's go ahead and let me show you what's going to happen. I'm going to use this input parameter, the input parameter that's called the control. And then here, C3 control. And I'm going to use the max depth right now. And I'm going to store result in the model A. Here it is. And now I'm going to take a look at the model A. This is my model A. But it's better to actually do the plot, right? So I'm going to do this. I'm going to do Control C, and I'm going to do Control V. I want you guys to see what the plot looks like, right? And then also as an exercise, an ungraded exercise, you can go ahead and explore the classification accuracy for this and see the impact of these parameters, right? So let's go ahead and plot this, and I'll show you what it's going to look like. And let me zoom in. Okay, so I want to have only 3 levels. That's what depth means. That I have no more than 3 levels, right? 1, 2, 3. Terminal nodes, right? 1, 2, 3. Here, by default, it's going to show the extended view. And extended view, it means that I see in this case it's a bar plot because I only have 2 values. If I had 3 values, this would have been a histogram, right? More likely it would have been a histogram. Or bar chart rather, right? Well, this is a stacked bar chart. Right now, this is a stacked bar chart. Okay, right now I see the stacked bar chart. Now take a look at this. It's looking just the satisfaction, year spent, and salary. Oh, and also the project worked on, right? It's highly possible that I'm not considering some of the variables that I did before, right? So let's minimize that. And what you could do actually, you could take this guy right here. See this? Where I'm doing the this. See, this is the confusion matrix here. And you can do like this, but you can, instead of model, you can do this. You can change model A. You can change it to model A and see what happens, right? So this is going to be the model A, right? This is what I'm doing. I built the confusion matrix on the trained data, but I'm looking at the model A right now. And I can also take this guy right here. I just take that, and I'm going to substitute model with the model A, right? And what I'm doing here, I'm trying to get the classification accuracy just to show you. See this? The classification accuracy is going to drop right now because I'm looking at less variables, right? So right now, see this? The tree depth is decreased, and so does the classification accuracy, right? So that's something to keep in mind. And I'm going to show you more input parameters in here. So you've got the mean split also. So that basically it's telling me how many, the minimum number of instances that I should have in my node before I can proceed with splitting, right? So if I have less than certain number of instances in a node, right, less than certain number of employees in the node, I'm not going to do the splitting, right? And there is also the mean bucket. It means that the terminal node, each terminal node has to have a certain number of instances after the split. Otherwise, we're not splitting. So in other words, just remember, you have several input parameters that sort of determine the depth of the tree, right? You have certain input parameters that control the depth of the tree or control when the splitting stops. Now, to read more about the decision tree, you type the question mark and then put C3. That's going to display the help page. See this? This is very excellent. This is excellent, the help page here. You can read about the methods and you can read about input parameters, because if you use them in your assignment, I'm talking about assignment, not exercise, it could add value to your submission. Now here, this is the C3 control. Remember what I was using to control the tree appearance. So you look at the help page for that as well, right? And here, this one, I'm just aware that this package has some examples. So, and it's using this pre-installed data set, and I can just see this example of decision tree model, right? So this is pre-installed, and it's given me the pre-installed decision tree model. Here, this is called the vignette. I know that this package has a vignette, so I can just run this, and it will open the PDF file in a browser, the browser that you have it configured on your computer as a default. So in my case, I believe it's going to open it in the Internet Explorer. Oh no, just open it in a PDF, okay? So this is about the package usage, right? So that's another documentation. And after this class, I'm gonna give your instructor these two scripts and a copy of the data set I used and the slides, okay? So this was the C3 implementation. There is another implementation, RPart, and they're different because they use the different criteria to split the tree and more. All right, so let's look at the RPart, recursive partitioning. You have to install this package, RPart package. Then the package is not available until you load it in memory. There are two ways to load it. You can use the library command or you can use it require. I'm going to use require for the change, and I'm going to run it. Now, I assume that you're running this from scratch. I have to write a script. I have to assume that you don't have this, right? So I'm going to reload my data, and I'm going to repeat the data pre-processing steps that I ran. They are the same. I want to remove my ID, and I want to check if I have missing values, and I want to handle my missing values. Remember, I'm replacing them with a min, and I always want to make sure that the missing values are gone, because sometimes I may miss something. They're gone, right? And then here, I know that these variables are actually a factor. I'll do that. Now I also have to do that. I have to set seed, because I want my result to be reproducible. So if I start working on my homework today and I'm not finished today, when I run it tomorrow, I want to get the same result, because I don't want to redo the homework from scratch, right? I want to use the work that I did on yesterday, right? Okay, so let's do set seed. Now I'm going to split in the training and test set. The reason is the same, because I don't want to overfit my model to the training data. Now what I'm going to do, I'm going to run the method. The method is called rPart, and this part is a formula. And here I specify the variable I want to predict, right? Which is employee attrition, tilde, and here I have to list all my predictors. But I'm lucky that this method accepts the wildcard. That is a wildcard. Here I'm specifying that I want to use the train data. Method is class because, well, that's because I'm doing the classification, right? So, and I'm going to set this output in a variable. So right now when I run the command, you don't see any output. It's because I put it in a variable. So model 2, this is going to be the textual representation, and I want you to notice the differences. See, I see different, totally different information now. Okay, let's take a look at this. Here, this is the number of variables in my training set, right? Here it's showing me the actual tree, and this thing here, this is the terminal node. The star still denotes the terminal node, but look, this is a root node. This is a total number of people who did not stay in a company and number of people who stayed in a company. This is a dominant value in the node, which is 0. Notice that in a C3 we did not get the dominant value, right? And here I'm getting the percentage of employees who did not stay and who stayed. For each node, I'm going to get this distribution, I'm going to get these percentages. Now what I'm doing here, this is my first split, and I'm splitting on the satisfaction level. I'm saying, okay, is my satisfaction greater than 4.65? Notice that it also picked the satisfaction level for the first split, right? So here, this is number of people who did not stay employed, who fell into this branch of the tree. This is the number of people who fall into this branch of the tree, right? Here, this is 2,170 people who did not stay employed, and 231 who stayed employed, right? They fall into this branch of a tree. On the other hand, see this? There is another part, the satisfaction level below 4.65. Here I have 902 people who did not stay and 335 people who stayed. So note this, right? This here, and if you add this one here and you add this one here, they will add up to this number. It's because this is our first split, right? Here, we're gonna do another split. We're gonna check at the year spent. If employees spend less than 4.5 years, this is what's gonna happen. I'm reaching the leaf node. It means that the dominant value is 0. So more likely, people who have a satisfaction score of 4.65 or greater, and if they spend less than 4.5 years in the company, more likely they did not stay. This is what I see according to my rules, right? Okay, now I'm looking at people who spend more than 4.5 years. At this point, it's not determined. I have to look at another variable, and I'm looking at the last evaluation rating. And I continue, right? I keep going until I no longer can split, right? So here I see my dominant value for each node. So this is one main difference. And the criteria that it's used for the splitting, right? Now what I'm gonna do here is I'll show you how to plot. This one is a little bit tricky. Oh, something else. In addition to textual representation, you can also see the variable importance, right? So that's a sort of like a satisfaction level. And you see, the higher the number, the more important it is. Yes. So that's basically one way to answer. Variable importance, you can look at that here too. Now, here, this is how to plot. This is the basic plot. Look, this one here will just plot the skeleton. You have to do this. And this will just do the skeleton, right? Now, I want to add the labels. This is my plot. But, do I like it? No, I don't. It's kind of like, well, you know, I can follow it, but I don't really like the appearance. Well, it's still functional, I can still read it, because, see this, I can say, my satisfaction level, is it less than this number? If it is, then I go this branch, I look at the year spent, then I'm going to look at the evaluation rating, and here are my notes, right? But, if you're like me, I like these things to look nice. There is a package called rpartplot. I have it installed already, but I have to put it in memory. Otherwise, I cannot use it, right? Now what I'm going to do is I'm going to plot the function called PRP, which stands for the rpartplot. Okay, much better, isn't it? This looks much better. So here I'm checking if I'm satisfied. If I'm satisfied, I'm taking this pass, right? And then I'm looking at how many years I spent. And if I spent less than 4.5 years, more likely I'm not going to stay in the company, right? So that's basically how that works, right? Well, which is, of course, this is very interesting, because usually if I'm satisfied, I want to stay, right? Well, I guess that's what it is, right? We have to interpret the data as is. Now, what else we could do is we can add more. There is an option that's called extra that's going to add more labels to the leaf nodes. It's going to show you the percentages, right? And also it's going to show you the dominant values and so on. The number of instances that fall in the node. Yeah. Or actually it's going to show you rather the node number. This is a node number. See this? It can do that for you. Now what we could do is we can also evaluate the model on a training set. Well, the idea is similar. Take a look at this. I'm using predict, and I'm going to run the table command. But I want it to look nicer. This is better because I can read what my predicted values and what my actual values are, right? Here, this one just will show me the proportions, right? So this is useful too. But then ultimately, what I want to do is I want to check my classification accuracy. which is 97%, believe it or not. It's doing better than the other model I used. Now I'm gonna run the model on my test set, and I'll store this values, the predicted values, in a variable. I'm gonna call it prediction, and let me run it. Right, then I'm gonna do type class. Here I want to print the tabulation of actual versus predicted, right? And then I have to look at the classification accuracy, right? So I want to do the same thing as I did in here, except it's going to be looking at the test data instead, right? So this is what I actually could do. So see this here, I can just go in here, I can copy the code, right? Because I thought it was there already, but that's fine. This is what we can do. We can just go in, and we can take that, and we can copy the code, right? Because I already have what I need to run the code, right? Here we go. Now, so what I did was, let's see, but before I do it, I have to store my predicted values in this variable, right? It's because I'm using this variable in the calculation. So let's do that, right? Like this, right? Oops. Sorry. Oh, I have to take this model. Sorry guys about that. I have to take this, right? I have to take this one, and I have to set this. See, it's because I'm storing it in a variable, right? And what I'm calling a variable, I have to use the same, right? Or ultimately I can just take this here. See this? I can take it here because this is what I'm calling here, right? I'm calling it this. So let's just take this. Let's not mess with this. Okay? So now let's do this. Run. And this is a classification accuracy, right? For the test data. Okay, take a look at this, compare it. It's about the same. So for the training test and test data, the classification accuracy about the same, so I don't have to be concerned with it. Now I'm going to show you something else. We just built the confusion matrix, right? There is a package in here that can do a similar job for you, and that's called the carrot package. And you can install it, and then you just do the require. Require will load it in the memory, because the package is not available until you actually load it in memory. So now what I'm taking, I'm going to run the predict function, and I'm going to store the predictions in a variable called predict. This is the test data I'm using, and I'm interested in a class. And now I'm going to call the confusion matrix function, and here are my predicted values, and this is the actual values, and then I want to label. I want to add the labels to my column and row. So let's go ahead and run this thing here. Why do you think I like it? It's because it shows me more information here, and I can show this for you. Look, did I have to do the calculation of this accuracy? No, I did not, right? And what I did for you guys here on the slides, there is a slide here where I spelled out, and I'll give you a copy after this class. I spelled out what each of these in the confusion matrix mean. So accuracy, notice that here, this is the confusion matrix, right? You have, this is a true positive. True positive means that where you predict, see that 0 is going to be the positive class, right? So you predict that employee will leave the company, and employee actually left the company, right? So this is called true positive. True negative, it means that you predicted that the employee stayed, and then the employee in fact stayed. And I'm showing you here how to calculate the classification accuracy. I'm just showing you the formula, how the method did it, right? It's just good to know. So, to do the classification accuracy is the sum of these numbers in the diagonal divided by total sum of numbers, or the number of instances in the test set. How many people are in the test set. The sensitivity, this is true positive, right? So the number of people who were predicted as they leave the company they actually left, over the number of people who actually left. So we're looking here at the percentage of people who were predicted as they leave, right? And they actually left. Well, we're looking at number of people who actually left, and out of those people who actually left, how many people were predicted that they leave. See this? And then we also have this specificity. We take the true negative, right? So we have 324 people. We predicted that they will leave, right? And how many people actually left? That's what we're looking at. And then this is a positive predicted value, right? And negative predicted values. So those are the metric, and I spelled out how to look at them. And also the prevalence. See this? So this is a true positive divided by number of instances. So this is 973 by total number of instances. Well, this is something for you. If you want to do something that adds value to your homework, right? I'm not talking about exercise. I'm talking about assignment. And you can also do this for the C3. You can run this confusion matrix for the C3. This will add a lot of values to your assignment submission, trust me. Because you want to look at the metrics. In addition to looking at the classification accuracy, you want to look at the metrics, because sometimes, in some cases, you would want to analyze the cost of making mistakes, right? Perhaps what is the cost of predicting that somebody who was predicted as the person is not going to stay in the company actually stayed, right? And what is the cost of making vice versa mistake, right? So sometimes you want to look not just at classification accuracy, you want to look at other metrics as well, right? So let's go ahead and return to this screen, the R screen. Now here, I showed you the confusion matrix. Similar to the C3, you can control the three depths, right? Similar to C3 method, you can control how far you want to split. So this is the R part control input parameter, and I want to do max depths in 3, right? That means that I want to stop splitting. I want to stop splitting at 3 levels. See this? I'm not splitting more than 3 levels. That's what basically I'm doing, right? This is the depth. Then I can also control the number of instances, the number of employees, so to speak, that should fall into the node to qualify for splitting. Like if I set the mean split 15, if the node has 14, it won't be split, right? We cannot split the node if it has less than 15. Or we cannot, if we split the node, if the terminal node result in less than 15, then we cannot proceed with the split. That's what it basically means. And you want to play around with these parameters. And as I promised, I'm going to give you instructor this code. Okay? Now here, this is something else for you to look at. There is something called the CP table, and this table will help you estimate the optimal depth of the tree. Okay? The optimal tree size, because if you noticed before, when I'm changing the depth of the tree, my classification accuracy changes, right? So basically, I don't want to underfit, and I don't want to overfit, right? So this is kind of like, is going to look at the error, right? We can plot this error, and the optimal size of the tree is the inflection point. You're going to look at the error plot, relative error plot, and then you're going to take the inflection point, and it's going to give you the optimal size of the tree. So in this case, it's about 8 or 9, something like that, right? Now, here is a documentation page. Do you remember? This is your friend. Whenever you type the question mark, it's going to show you the documentation page. This one is a documentation page for control parameters. And this one is going to run some examples. Well, I just know that this package has examples. See that this is a different plots. And the nice thing about it is that it shows you the command it ran to build this plot. So, and it's using one of the pre-installed data sets, I think. And you can always look at the code because R is an open source. You can always check. Yeah. Now, for this one is also, you can check this one. This is you can learn more about the model summary output, right? Okay, now this is for people who pay the undivided attention while attending this WebEx or at least watching the recording. I'm going to show you something fancy. Look, for this you have to have two packages, Rattle package and RColor Brewer. I'm going to load them in memory. And I'm going to plot my Model 3. Let's see if I build it first. I have to go and I have to build it first. Here, let's build it. I don't remember if I ran this command. Okay, this is my Model 3. Now what I'm gonna do, I'm gonna do the fancy plot, and it looks really beautiful. Okay? Okay, this is what I will do. I'm gonna do this and do this Model 3. See this? It looks nice and pretty. And I can zoom in and examine it closer. Well, it's a little bit hard to read, but I'll tell you that it's possible to tweak the fonts. You can play around with input parameters. And you can also tweak the colors. Like, see this? I'm going to show you different colors here. Right? And basically, in your course content, you notice that there is a decision tree plot. This was done in R, and it was using the Rattle package and the RPart method to build the tree in R. So that tree is for the iris data classification, and it was done in R. Now this web page, you might find it useful. It has additional example on this type of plots. All right. So this is basically how to plot. So you can, if you like visualizations, you can make something that looks nice. And also it will help you learn R more in depth, because you're reading about input parameters and playing around. Right? So I talked for about an hour. Let me see if we have questions, because you know that Elena loves questions, and she loves people who ask questions. Right? So let's see. Let me have your questions. Let me check the chat quickly if there is anything in the chat. Nope. So nobody has question. Everybody is confident with doing the homework assignment, right?
Hello?
Yes.
I have a question. So you just showed us C tree and R part. Are
Yes.
they the same analysis using different methods?
Well, it's different. It's different, but it's also decision tree. In R, you have several decision tree implementation. Yes, I would like to show students too. I always like to show too. And also another reason, another reason is that you might see it. You might see it later on too. I like to show too. That way, when you're doing an assignment, you have choice. Yes. And there is also a method, called tree, just tree. It was used for testing mostly, but yeah.
Will we have a copy of both of the examples that you have?
Yeah. Yes, I'll give you both. And you also have a recording In the classroom, I believe
Okay.
there is a recording from last semester, and I used a different data set in there. That one, I believe I used the student survival. And what you find interesting is that the student attendance, right, the number of absences is significant predictor of the student, if a student is academic risk. Yeah. And also, if some of you remember, you may have seen the data set before, data 610. Yeah, you might have seen both employee attrition and student at risk. You've seen those both data sets in data 610. More likely.
Okay.
Yeah. So if you may still remember your notes, I found that the classification accuracy that this model returns is somewhat similar to what I got in Watson Analytics. So,
Right.
yeah, you may remember I did the demo for the Watson Analytics. Yeah.
Yes, I remember.
Yes, and that's what I'm doing. I'm reusing the data sets because they're really good for the decision tree lesson. Yes.
Okay.
Yeah.
Perfect.
I'll let you have this. This is, I call it customer service, so it's all yours. That's your script is going to be. All right?
Thank you so much.
Sure, you're most welcome, yes. But, yes, you will see R later on in the program too, data 650. So make sure that you remember how to write an R script. That's important. Yeah.
Got it.
So, yes, you will see it in the 650. So, the first assignment, more likely in 650, is going to be in R, text mining. Yeah. Well, you'll see. Anyhow, let's see if we have questions. I love questions. Yeah. But yes, I like to show two implementations because that way you have choice. Yeah. And yeah, let's see if we have questions. I love questions. It's an excellent opportunity for you to, you know.
So for the exercise, another question, sorry. So for the exercise and the instruction that's provided is completely different from what you're showing right now. So we can still use the instruction from the exercise to do our at least exercise 5, right? And then use this for assignment 3?
Well, yeah. Basically, exercise shows you less. I'm showing you more. It's because you'll be using this also for the assignment. I'm showing you more. Basically, yeah. In exercise, you're doing the pre-processing, right? And well, the reason I know that is because I wrote the exercise, and you're doing pre-processing, and then you also splitting data into training and test set, right? Then you're building a model, yeah. You're evaluating model on the test and training data, and you're doing a plot, right? I'm showing you more than the exercise does. And the reason is because I want to make sure that people who attend the WebEx have an opportunity to learn more. People who attend the WebEx and people who watch the recording, they are learning beyond what's in an exercise document. You learn the topic more in depth. So in other words, I'm not just sitting and repeating the handout. You get more.
Right.
Yeah, I want to make sure you have a deeper understanding, more in depth, because you have to do the assignment, and I'm kind of like saving you a little bit of time you would have spent on reading and researching.
Right.
Yeah.
Right. Awesome.
Yeah. No, basically you're doing it. You're doing it's basically exercise is a subset of this. Trust me. It's a subset of this because yeah, you're doing the split, right? And then you're doing building the model. You're just not doing it as much. I'm showing you more options what can be done, right?
Right, and that can be used in the assignment.
Oh yeah. Well, you will use it in assignment, yeah. Because the assignment is different. It does not tell you that you explicitly how far in depth you have to go, but it will add value. Especially if you look at the optimal depths of the tree. Yeah, then the instructor will be impressed. Of course, it adds value. And if you look at the input parameters, see like you're discussing the pruning, you're discussing the overfitting, that shows that, yeah, it means that you're kind of like applying the concept to the data that you're analyzing for your assignment. It could add value. Yeah. Huh? What was that? No, I'm just trying to... What's that?
No, I think I'm good with questions. If we have any more questions, we can just contact you directly, correct?
Oh yes, you can always post. Yes, definitely. And of course, I mean, yeah, I'll let the instructor know. They're aware that I always show 2 methods, 2 implementations. Well, and the reason is because you're gonna see this method later, and because that way you have a choice for your assignment, and that way you can see things differently. You see that R has more than one implementation. R has a variety of packages, and the same thing can be done differently. And similar for the confusion matrix, right? For your exercise, you can just use a table command. But for your assignment, if you want to go more in depth, then you can look at the package and use the confusion matrix. You can use that package that I showed you to build confusion matrix. Basically, you're just looking at more in depth. And I had people asking me to actually show the metrics. So that's the reason it was added in here. Yeah. Yeah, and see this basically I'm also using table command, but I showed you extra. I showed you how to add the labels. Go ahead and add the labels in your exercise too, because it will help you read the matrix. Yeah.
Right, thank you.
Sure, yes. Yeah. I usually show more when I do the demo. Yeah. Well, so let's see, what questions do we have? See, I like when people ask questions, but did you guys find the WebEx helpful? And let me know how often would you like to do that?
I mean, every assignment will be very helpful.
Sure. We'll see what we can do. Yes. We'll see what we can do. Yeah. So we've got the decision tree. What else we have? We have neural network and clustering. Okay. Okay. We'll discuss with the instructor. Okay. So we have more questions? More questions? So you're going to have both files. You're going to have the data set. You're going to have the slides, because on the slides what I did was I put some summary for you, what I talked about. Just summarized. And if you look at it, R part, and if you look at the C3, you will see the differences in how the output is displayed. And it just, yeah. Well, yeah. And I'm sure that there is even more implementations. Some people write their own packages.
And this will all be uploaded as soon as possible?
Yep, when I get the recording. I have to get the recording from the server, and then I'm going to email it to the professor, and then they will upload. Yeah. There are 2 sessions. Yes, I'm going to email it to the Professor Bati and Professor Gates, and also include Nivedita. Yeah, I'm going to include her in the email. Right? So that's going to be as soon as I get the recording. Then I have to put the recording on my YouTube channel, and then you're going to get this. Yeah, you'll get it. Right? Yes.
Awesome.
Yeah. Yeah. Go ahead. Guys, feel free to ask questions. I love questions. Some of you may have met me in 610, and then later you'll probably meet me in 650. So I usually do art classes like 610, 10, right? 30 and 50. Is it possible for you to one with text mining? Okay, I'll discuss with the instructor. I'll discuss, okay? Yeah, I'm going to discuss it, and we'll see what they say, because it's going to be, ultimately it will be their decision, but yeah. And then text mining will come back. We'll do that in Data 650. The first assignment is in a text mining. Yeah. So you will see it again. Yeah. And you will also see the using Arvis databases when you come to 650.
Awesome.
Yeah.
And you will ask the professor if you can do every assignment like this review before like every assignment, because this is very helpful, especially when we're doing our analysis phase, so that we know what to include and what not to include, so we don't waste our time looking for other information that are probably not correct.
Sure, I'll talk to the instructor, because basically I've been with UMUC for more than 9 years, and I'm one of the leading TAs, so that's the thing. So sometimes I would do the class like this for data 610 students for Watson Analytics, because I manage the accounts for Watson, and sometimes I do the demo for the 613, and then I TA 650. I have a 650 session. Yeah. So
Awesome.
you will see me. Yeah, you will see me later, for sure. Yeah. So, do we have more questions? Yeah, but this will be taken into consideration. I'll talk to professors. Okay.
Thank you.
Okay, sure. Any more questions do we have? If no, then let me stop sharing my screen, and I'm going to end the recording, and I guess we'll call tonight, and then once I receive all of the recording, I'll put it on YouTube, and I'm going to send all the information to your professors. Okay, so I want to thank everybody for attending tonight, and good luck.
Thank you.
Mm-hmm.